Welcome to our today's lesson. Teacher Marita. We are looking at Kcse revision, chemistry, paper 2, questions, revision questions, reaction rates, and the chemical equilibrium. Question 1. The curve shown below were obtained when two equal volumes of hydrogen peroxide of the same concentration were allowed to decompose separately. In one case, manganese oxide was added to hydrogen peroxide. This manganese oxide is acting as a catalyst. In this rate of reaction and chemical equilibrium, we have factors affecting the rate of reaction, likes of temperature, likes of pressure, likes of concentration, likes of surface area. So understand well what will happen if the temperature is increased or decreased. What will happen to the equilibrium if the pressure is increased or decreased. What will happen to the equilibrium if the concentration of a given substance is increased or decreased. So in this question here, we have a volume of a gas, and then we have time in seconds. Then we have curve 1, then we have curve 2. So the question is, which curve represents the decomposition of hydrogen peroxide with the manganese oxide? Then after that you explain. So you can look at this one is curve 1. Why is it curve 1? Because it is steeper, and this manganese oxide, it is acting as a catalyst, and therefore it increases the activation energy of the reactants, then increases the number of effective collision, and that is we can have a faster rate of the reaction. In an experiment, 0.8 grams of magnesium powder was reacted with Kcse dilute sulfuric acid at 25 degrees. The time for the reaction to come to completion was recorded. The experiment was repeated at 40 degrees. In which experiment was the time taken shorter? Explain your answer. This question is testing on the temperature as a factor which is affecting the rate of the reaction. So question 1 was testing on the effect of a catalyst on the rate of a reaction. So this question 2 is the effect of temperature in the rate of the reaction. You can see the temperature was at 25 degrees, and then the experiment was repeated at a temperature of 40 degrees. So the reaction at 40 degrees, the question was, you were supposed in which experiment was time taken shorter? Explain your answer. The reaction at 40 degrees. Higher temperature increases the kinetic energy of the reacting particles, which causes them to move faster, hence increase number of successful collisions. State and explain how the rate of a reaction between zinc granules and steam can be increased. The question is also testing another factor of surface area. Increase in surface area increases the rate of the reaction. Now we have zinc granules here, and then we have steam. So state and explain how the rate of a reaction between zinc granules and steam can be increased by using zinc powder, which has a more surface area than granules, hence increases the number of successful collision. So here the question is testing on the one factor affecting the rate of the reaction, which is the surface area. Increase in surface area increases the rate of the reaction. Bismuth chloride, this one here, reacts with water according to the equation given below. So we have, this is bismuth reacting with water. This is a colorless solution here. Then we have bismuth hypochlorite, which is white. Then we have hydrochloric acid. So look at it. We have, this is a colorless solution here. That is bismuth chloride reacting with water. Then we have bismuth hypochlorite then plus water. This bismuth hypochlorite is white. Then state what will happen when a few drops of hydrochloric acid are added to the mixture at equilibrium. The question is testing on the effect of concentration on the rate of effect of concentration on equilibrium. That if we increase hydrochloric acid, what will happen here? More the white solid dissolves, so we can have more of the white solid dissolved because the concentration of hydrochloric acid has been increased. Give a reason for your answer. Addition of hydrochloric acid favors the backward reaction. So addition of hydrochloric acid favors the backward reaction. In a Haber process, the optimum yield of ammonia is obtained when a temperature of 450, a pressure of 200 atmosphere, and an iron catalyst are used. So in a Haber process, there are the conditions for the production of ammonia. So one condition, there must be a temperature of 450, a pressure of 200 atmosphere, and then we have a finely divided iron catalyst. The reason why it is being divided is to increase the surface area for a more yield of ammonia. So look at this question here. We have nitrogen gas and then a ratio 1 to 3, that is hydrogen gas, nitrogen reacting with hydrogen, then we have a formation of ammonia. Then the forward reaction here, it has a negative. The negative means the reaction is exothermic. So we have two types of reaction here. That is an endothermic reaction, which has a positive value. Then we have an exothermic reaction, which is a negative value. So when you look at this one here is a negative, it means the forward reaction here, this forward reaction is an exothermic reaction. So how could the yield of ammonia be affected if the temperature was raised to 600? So it was from 450, the temperature was raised to 600. The effect of temperature on equilibrium. To answer this question, you need to check a question on temperature. You look at two types of reaction, whether the forward reaction is exothermic or endothermic. If it is a negative here, it means the forward reaction is exothermic. Then what will happen? If the forward reaction is exothermic, it means the backward reaction is endothermic. If we can have a positive here, a positive means the forward reaction is endothermic. That means the backward reaction will be exothermic. In our question here now, our forward reaction is exothermic. And increase in temperature, it favors an endothermic reaction. So that is one very important point you need to understand, that an increase in temperature, it favors an endothermic reaction. So you check if the forward reaction is exothermic, then the backward reaction is favored because it's an endothermic reaction. So let us answer our question. How could the yield of ammonia be affected if the temperature was raised to 600? A yield could be lower. Increase in temperature will favor the backward reaction, which is an endothermic. Give one use of ammonia. Ammonia, it has various uses. So one use of ammonia, it is used in manufacture of nitrate. It is used in manufacture of nitrogenous fertilizer, for example, ammonium nitrate. The salivate fertilizers, for example, sodium salivate. So don't say it is used in the manufacture of fertilizers. You should be very specific when answering this question. So it might be either the manufacture of ammonium nitrate or ammonium phosphate or ammonium salivate. So you avoid saying that is used in manufacture of fertilizers. you can go back to Form 3 work, you will get very many uses of ammonia. What the conditions is necessary for equilibrium to be established? The conditions for equilibrium to be established, it must be in a closed system. When calcium carbonate is heated, the equilibrium shown below is established. That is, calcium carbonate, it decomposes, then we have calcium oxide, and then we have carbon dioxide gas. Look at it. On the left hand side we have one molecule, on the right hand side we have two molecules, because we have this is one molecules of calcium oxide and another molecules of calcium carbon dioxide. So we have two molecules here, and then we have one molecule on the other side. That is the backward reaction. We have one molecule. The forward reaction, we have two molecules. That is calcium oxide and CO2. How could the position of equilibrium be affected if a small amount of a dilute potassium hydroxide is added to the equilibrium mixture? So the question is testing on the effect of concentration on the equilibrium. If addition of concentration increases concentration or reduces concentration. So here we have potassium hydroxide, and where you see carbon dioxide and the potassium hydroxide, there is a reaction, because potassium hydroxide would normally absorb the carbon dioxide. In place of this potassium hydroxide, sodium hydroxide may be used. So how could the position of equilibrium be affected? If a small amount of dilute potassium hydroxide, if potassium hydroxide will be added here, it will reabsorb this carbon dioxide gas. So the equilibrium shift to the right. Equilibrium shift to the right because dilute potassium hydroxide absorb carbon dioxide, hence favoring the forward reaction in which more of carbon dioxide is formed. State and explain how increase in pressure affect the yield of carbon dioxide. You look at it. This question of pressure as a factor which is affecting the rate of the reaction. You check here the number of molecules. The increase in pressure favors the side which has a fewer molecules. So when you look at this question, the forward reaction has two molecules, the backward reaction has one molecule. So this side will be favored because there is only one molecule here compared to the other side where we have this, and this one we have two molecules here. So increase in pressure favors the backward reaction, which has a lesser volumes because solids have a negligible volume. The sketch below shows the rate at which substance K is converted to J. So we have this substance K was converted to J. Study and answer the questions. So we have this is a concentration, then we have time. So we can look at this curve K. This curve K, this substance was converted to J. Why could the two curves become horizontal? So the two curves becomes horizontal at this side here because equilibrium has been attained. Look at question number 8. At the 20 degrees, that is nitrogen dioxide gas, nitrogen dioxide gas and nitrogen dioxide gas, gases exist in an equilibrium as shown below. So you can see this is a brown nitrogen dioxide gas, then we have this pale yellow nitrogen and the trioxide. The forward reaction is negative. It means the forward reaction is exothermic. So what will happen here? If the temperature will be increased here, it means that the backward reaction will be favored because the backward reaction is endothermic. For you to answer this question of temperature, you check if the forward reaction is endothermic or exothermic. If it is a negative, it means the forward reaction is exothermic. Then if it is a positive, it means the forward reaction is endothermic. Then the backward reaction is exothermic. Now state and explain the observation that could be meant when a syringe containing a mixture at 20 degrees is immersed in ice cold water. When you immerse a syringe containing 20 degrees immersed in a cold water, of course the temperature will decrease. So if the temperature will decrease here, there is a yellow color intensifies. Lowering the temperature favors the forward reaction, which is exothermic. The volume, when the volume of the gases mixed in the syringe is reduced, what will happen? A yellow color intensifies. Lowering the volume leads to increase in pressure, which favors the forward reaction, which has a lesser volumes. The diagram below is a sketch of the graph of an uncatalyzed decomposition of the hydrogen peroxide. You can see before this one here we have this hydrogen peroxide. Hydrogen peroxide can only decompose in the presence of potassium permanganate. Potassium permanganate, manganese, which acts as a catalyst. So here you are supposed to, on the same axis, sketch the graph for the decomposition of hydrogen peroxide when manganese oxide is added. Adding the manganese oxide, it is acting as a catalyst, and a catalyst has two things. It will either increase the activation energy or lowers the activation energy. In this case here now, the manganese oxide lowers the activation energy, so we are expecting that curve when the energy has been lowered to be look like this one. So this is the, on the same axis, this is the curve. In an enclosed system, aqueous iron 3 chloride reacts with hydrogen sulfide gas. Remember the properties of hydrogen sulfide gas in form 3, whereby the gas is used as a reducing agents. It can reduce a yellow iron 3 chloride solution to a green iron 2 chloride solution, and then we have a yellow precipitate of sulfur. Go to form 3 work, and then you will have the hydrogen peroxide, a reaction of hydrogen sulfide gas as a reducing agent in form 3. So look at this question here. This is iron 3 chloride, which is yellow solution. It has been reduced to a green iron 2 chloride solution, and then of course we have a yellow precipitate of sulfur. State and explain the observation that could be made if a dilute hydrochloric acid is added to the system at the equilibrium. The question is testing on the effect of concentration on equilibrium. So there is an increase of the concentration of hydrochloric acid. What will happen here? A yellow color intensifies. This yellow color here, yellow solution of a yellow color of iron 3 chloride intensifies, and the yellow solid dissolves. Addition of hydrogen chloride, we received the equilibrium to the left. Now, a certain mass of metal E1 reacted with excess hydrochloric acid at 25 degrees. The volume of hydrogen gas separated was measured after every 30 seconds. The results were obtained as shown below. So you can look at this this graph here. So this was the original graph. We are supposed to name one piece of apparatus that may have been used to measure the volume of the gas separated. So one apparatus which is used to measure the volume of the gas separated is normally at the syringe. On the same axis, sketch the curve that could be obtained if the experiment was repeated at 35 degrees. So on the same axis, sketch the curve that could be obtained if the experiment was repeated at 35 degrees. So if the experiment was repeated at a temperature of 35 degrees, this is the curve, so it is steeper. So this is the curve that it is obtained on the same axis, because increase in temperature, it increases the rate of the reaction. So we should have the steeper graph, which looks like this one. Then of course you are supposed to explain the shape of the curve that we have that above, that the molecules of the reactants have a higher kinetic energy, leading to more effective collision, hence faster rate of reaction. The following reaction is in an equilibrium. The following reaction is in equilibrium in a closed container. So we have, this is carbon reacting with water, we have carbon monoxide, and then we have hydrogen gas. So the number of molecules on the forward reaction is 2. The number of molecules in the backward reaction is 2. So we are not going to have no effect of either increase of pressure or a decrease in pressure, because the number of molecules on the right hand side is equal to the number of molecules on the left hand side. So state giving a reason how an increase in pressure could affect the amount of hydrogen. The amount of hydrogen could reduce. The amount of hydrogen will reduce. Increase in pressure to shift the equilibrium to the side which has a fewer molecules. But according to this question here, the number of molecules on the right hand side, we have 2 molecules here, and then we have 2 molecules here, and then we have 2 molecules on the other side. So this one here is wrong, because the number of molecules on the right hand side is equal to the number of molecules on the left hand side. So there will be no effect in the increase of pressure, because the number of molecules are the same. The energy level diagram below shows the effect of a catalyst on the reaction part. That is the reactants, and then we have the product. This is a catalyst, then we have an catalyst. So a catalyst means here the catalyst has lowered their activation energy. What does the point M represent? Point M here, this part here, it represents activated complex. With reference to the energy level diagram, explain how a catalyst increases the rate of the reaction. As you can see from here, a catalyst lowers the activation energy of the reacting particles, therefore increasing the number of successful collisions. Nitrogen and hydrogen react to form ammonia gas, as shown in the question below. So we have that is nitrogen and this one and hydrogen, they form ammonia, and of course we have this. We can say that this delta H is equals to be a negative. A negative means that the forward reaction is exothermic. The figure below shows how the percentage of ammonia gas in the equilibrium mixture changes with temperature. So remember, this is a reaction in the Haber process where we have some conditions, a temperature of 150, a pressure of 200 atmosphere, and of course we have a finely divided iron catalyst. So this figure now shows the percentage of ammonia gas in the equilibrium mixture changes with temperature. Then we are supposed to explain why the percentage of ammonia gas changes as shown in the figure. The forward reaction is exothermic because it has a negative. Therefore, increase in temperature it favors a backward reaction. When the backward reaction is favored, increase in temperature, the equilibrium shifts the equilibrium to the left direction in which heat is absorbed. On the axis below, sketch a graph showing the percentage of ammonia gas in equilibrium mixture changes with pressure. So when you look at that question, we have on the left hand side we have 4 molecules, and then on the right hand side we have only 2 molecules. So the forward reaction is favored when the temperature is increased. Therefore we are expecting this kind of a graph. We expect that kind of a graph. The figure below shows how the rate of the following reaction varies with time. That is A plus P, you will get C and D. So we can have this one is rate Y, and then we have it shows like this one time in minutes, then we have this is X, this is Y, this is curve 2, then this is curve 1. Which of the two curves represents the rate of reverse reaction? Which of the two curves that represents the rate of a reverse reaction? Give a reason why. It is curve 1. The amount of product are increasing. So you can see when the amount of product is increasing, we can have the reverse reaction. When the amount of the product is decreasing, we can have the reaction is not, it cannot be, it is not a reverse reaction. So what is the significance of points X and Y? So we have this is X and then we have Y, where the reaction has come to completion. Point Y, so point X is the time at which the equilibrium has been established. So this one here, the equilibrium of both curve 2 and curve 3 have come the same horizontal, so the equilibrium has been established. Point Y, the rate of a forward reaction is equal at this point here. The rate of a forward reaction is equal to the rate of the backward reaction. So the reaction is at equilibrium. On the same axis, sketch how show how the catalyst will affect the position of the equilibrium if the reaction is carried out in the presence of a catalyst. So if the presence of a catalyst, this is what you can see here. In the presence of a catalyst, curve 2 will appear like this. In the presence of a catalyst, curve 1 will appear like this one. And then the point at where the forward reaction and the backward reaction will be the same, it will appear here. Then we have X of course becomes there. And one thing to note, a catalyst does not affect position of equilibrium. A catalyst does not affect the position of equilibrium, but only causes the equilibrium to be attained within a shorter time.